And then when we come down here, when we load up the pixels, our result.pixels will equal pixels, our result.width will equal the header width, and our result.height will equal the header height, like so. And then we just have to kind of, what is the problem? That's game state. There we go. And so now we should be able to load it, and hey, it does exactly the same thing it did before, but now we can load any bitmap we want. Now that we can load any bitmap we want, things get pretty easy. If we want to load lots of bitmaps, right, we could just load anything that we wanted to, right? Load player. Of course, our player, I don't know if you noticed this, or I should say our hero, is broken up into pieces that have to get assembled, right, like that, for our hero, and load to want to do. So let's go ahead and do that. We'll pick one of them, let's say move it, you know, the for loading right here. So we're going to go ahead and do player head, like that, and this will be, so test hero, there we go, test hero, and I'll load the front one. So test hero front underscore, so basically we need to do 3 of these. So we have test hero head, test hero cape, test, there we go, we've loaded all of those in, and hopefully that will just work. Let's take a look. And so let's see what we got here, people. Look at that. We've got some very nice hero graphics all loaded in. We could just cut and paste this code that displays the other thing, but really what we'd rather do is just obviously have a utility function that draws a rectangle on the screen, but instead of drawing it the old school way, this time it will actually just go ahead and blit graphics for the screen. So what I want to do is I basically want to copy this stuff out, right, entirely. Just go ahead and eliminate that and replace that with something that's basically like, you know, information. I don't actually know what it is. And so I basically want this to be bundled up so I can call it multiple times and draw the hero as well. So here we go. Let's go ahead and get that in there. So what it's going to take yet, we'll find out when we actually go to type it. So here's our draw rectangle call, and our draw rectangle call and our draw bitmap call are actually quite similar. They have to work on this blit to the point where we can actually do something of similar quality to our draw rectangle. Because remember, when we did our draw rectangle, a little more industrial strength than what we had here. Although at first we could just use exactly what we have here and assume that we always pass correct coordinates that are never actually going to. So let's start off. I guess let's start off simple and just do that. So let's start off by saying we have a draw bitmap call. Let's go ahead and use reals. We're going to pass floating point values for their x and the y. And then we're going to pass a loaded bitmap, and we want to be able to basically, we're going to need that buffer, obviously, because we need to actually draw that in there. And then we'll just assume that x and y now half a second after we get everything working. So we have our bitmap now, and so we don't need backdrop anymore, and backdrop here becomes bitmap. I guess most of this code just kind of works, except we now have a starting x and a starting y. So basically we need to do this sort of code that we did before, where we do a rounding operation to figure out what the actual x and y are for the blit, you know, more specific, to be integers that we can actually use to specify a particular pixel, not something in between pixels. All right, so then we can go ahead and, in fact, I guess what we could actually account for just that movement here by saying that the blit width, it starts out being the bitmap width and height, but if the blit width is, what we actually want to do is say that if the x plus the blit width is greater than the screen width, then we need to go ahead and adjust, if you will. In fact, I guess we could, you know what, we could do this very similar to how we did, now that I think about it. We could just use the same basic code as we used for our rectangle, right? There's really no, we know that we have an is, right? So we could really just use this code almost exactly as it is, right, in here. I could just start with this. So push that down a little bit and say, all right, we start with this code. We go ahead and say we have the min x, the min y, and those are equal to the rounded version plus whatever the bitmap width is, right? That's going to be the other end of our rectangle, right? Because we know that we're still filling a rectangle on the screen. We're just filling it with specific color values instead of one color value, right? And so we can basically construct the same rectangle, do the same clipping that we were doing, and say, all right, this code is exactly the same, right? This is exactly the same loop. So we can still use, you know, we can still use in order to get the x and y in there. All right. So our dest row calculation The actual part that fills the rectangle is operating exactly, thing works basically exactly the same. So the only thing that has to be modified now is that we actually have to change where we're pulling our source row from, and you'll see that in a second. So let's go ahead and say source row needs to be changed based on clipping. All right. So I think we can proper. So I think that's correct. Oh, wait, but I need to actually change it so that our x and y's loop the way that they should. So this is actually supposed to be loop. We're doing the between the min and the max now. So there we go. And now when we do our draw bitmap call, we should be able to already call this for drawing that game off the now what amounts to a draw bitmap, the draw rectangle call, but instead now I can pass it a bitmap. So I can pass the backdrop. We're drawing the backdrop at 0, 0 for now. And so right, nobody is crashed. Go up to that draw bitmap call. We know we have the hero head, and we can even draw it, in fact, at the location of the hero if we wanted to. When we draw the player's locator left, player top, we'll just go ahead and pass that. Player top, oops, player left, player top. We could just go ahead and pass that. And there's our little dude. He doesn't look particularly correct, though. What's wrong with him? So as you know, how would I do this? I'll go to handmade, data, test, color channels, but you also have a fourth channel, and that channel is called the alpha channel. Now, our renderer, this is going to work well. So what I'm going to say is, let's talk about one way we could easily implement this for our testing purposes. For our testing purposes, what we can do is basically do exactly what Photoshop or anything else does, where we basically just think about things in terms of background, right? And then we want to stick our guy on it. And basically what else says there was actually a shape, and we won't touch what's underneath in the places where it's not. So we'll basically do compositing very much the way you would think about it in Photoshop, where you have one layer and your base isn't anything, and that gives you the cut out. You can still see through to the thing that was underneath. Basically, what tells us to thing, we've got our trees, they're there, and then we've got our guy, and he's got the alpha channel on him that says where things exist. Two values, right? So it's basically a bright at that particular point. So what we would going to go ahead and get complicated. It's a very simple thing to do, so it might be a good one to start with. So basically what I want to do in here is I want to move this bit scan result. I want to move, we are on a compiler that can do it really quickly. It will do it and not have to go through this for loop, if that makes sense. So really what I need to do here is I need to be able to figure out whether or not, basically whether I'm on, what compiler I'm on, if that makes sense. And as you know, as I said, I talked about quite a bit at the beginning, you want to keep all of your stuff segregated as much as possible in terms of, and you'll notice none of this stuff leaks out into our main code. All the Win32 specific code is all in here, right? But there are layer that did this operation, right? And that would keep it, and I could even pass in a pointer to that function so it was completely isolated. I could do all kinds of stuff. But the problem is the only reason why you ever we didn't care about performance, we'd just run this for loop, right? So the intrinsics file, the whole point of this intrinsics file is going to be this is the place where we make a compromise and say that this is the place where we're allowed to do platform-specific, non-specific stuff, if that makes sense. And again, the only reason we're doing that is for performance. If we didn't care about performance at all, if we literally just had no performance concerns, then there would be no reason to do this. There'd be no point. You would just always do things the way we had been doing them. But in the case of intrinsics, which you're only using really when you're caring about performance in the first place, want to have it isolated again. Even though you're sort of saying it's okay to mix things up a little bit here, you still want to bring in that sort of non-independent parts of the code, right? So that's basically what we're going to do here, because this compiler happens to support this bit scan forward thing, right? And we want to do from LSB to MSB, so we're basically going to call this one. We know that in this case we're scanning a 32-bit value. So basically what we're going to do here is we're going to call this bit scan forward. The result found is going to be equal to that return value. We're going to pass the address of the index that we wanted to be set, and it'll set it, and then we're going to pass that value. And so that's just going to allow it to do it right there. And we're going to make sure this is marked to inline, so hopefully if the compiler isn't dumb, it will go ahead and say, oh yes, we can go ahead and inline this directly and turn this into a instruction, right? Go back to our handmade, I believe it's handmade platform, right? Yeah. In handmade platform, what I'm going to introduce at the top, kind of like, we have this sort of basic, this is like the basic setup for the code. This is what has to happen in the code. I'm going to do a little thing here, which basically says, compiler MSVC is 0, and maybe compiler LLVM, because I know those are the two things, at least, that we will compile under, right? And what we will do is we'll sort of do an if here on some kind of thing. Basically, compiler MSVC and if and def LLVM, like this. I could write these out a little. So what I'm going to do is, if the compiler variables, and maybe I'll even make a little section here, like this, and this can be, note Casey types, like this. Thank you, Emacs, for indenting me. It's finding the C++ bracket up there and doing the indentation, which I didn't actually want to do. What are you going to do? Whoever is building us, our batch file, whatever, if they want to explicitly set what the compiler is, then we'll just let them set it. So basically, we're only going to set these if they're not, if they're not already set, if the compiler is not set at all, right? If we have no compiler set whatsoever, right? This sort of thing. Then inside here is where I'm going to actually try to determine what the compiler actually is. So if neither of the compiler things have been set by anyone, then I'm going to go ahead and try to see what the compiler actually is. And MSVC, for example, will automatically define something but I want to actually go see what it actually is before I make that proclamation. Underscore MSC is 1, right? And then what we'll also do is we'll do an else here. And in this case, we'll just assume, maybe even like that. And so eventually we'll do something a little smarter than that as we go. But right now we're only compiling at MSVC. So, for now, that should be good enough. So when we actually do that, let's take a look at what happens here. Oh, right, we have to undefine, and then I got one forward is not defined, and that may for that to exist somewhere. Let's see. Well, it looks like we just need to do that, or do we actually have to pound include in trin.h? I'm not actually sure if we need to do that or not. We could take a look. I guess the first thing we could do is try this first and see what it does. So if we're defining MSVC, we can basically now have our little here, such as that pragma. Intrinsic function not declared. So okay, so I guess we have to include this file as well, which is the intrinsics. And unsigned long star. Why not? Types pointed to are unrelated. Is that really true? Why would those be unrelated? I guess unsigned in and unsigned long are technically different types. Oh, the mysteries of C++. I've been programming it for so long, and yet things like that always still confuse me. I'm like, what actually do you believe the technical difference to be between those types? And I have absolutely no idea. Oops, put that in the wrong place. Guess what? It does. And now let's take a look in there and see what it actually did differently now when we step into it. So if we step in here, you can see that this is actually using. Essentially what happens here is, do you see this BSF? That's bit scan forward. It's literally one assembly language instruction that does all. That is so much more concise, certainly, to the processor, and it's probably going to be much faster than if we were to actually have to code the loop. What it's going to do here is going to move the value, this thing right here, it's going to load that value into the EAX register, right? And that's this register right here. It's a little confusing because we're in x64 mode, which means that it uses RAX to denote the AX register because it's 64 bits long. But really what we're talking about is we're talking about the bottom portion of it here. It just loaded it right there. And now it's going to call that BSF function on the value in the register to load it out, right? It goes ahead and does that, and the destination is and that's the result that we were expecting, right? That's what we wanted it to actually have. Again, it's in hexadecimal, which is why it looks like an 18 instead of a 24. But you know, that's just well, you know, I can here you go. So OX18, right? You can see that that's just the hexadecimal right there. Did like the entirety of this loop, right? So that's intrinsics in a nutshell. They're really pretty simple, and basically what we want to do is we want to do those for anything where there is a convenient CPU instruction so that we can access it, because we don't want to go around, especially when we start getting more time-critical code, we don't want to go around wasting a lot of that stuff that the processor could do for us by obfuscating it. Now, it's possible that the compiler might have actually been smart enough sometimes, depending on the compiler, to actually realize, right? And so now we've done that. And we're in good shape. So now we're loading our stuff, and we're pretty happy. But if you actually take a look at what happens here, you'll notice that we would like to be able to composite this guy on top of things, and right now we're not actually doing that, and so that brings up use of the... well, you know what I'll do first? I'll basically show you the really simple version first, and then we'll talk about it a little bit. So as you know, I'll go to handmade data test, and I will load up that hero front head. There we go, edit with GIMP. So if we look at this here, you can see that basically you've got, you're probably sort of, even if you don't know exactly what that is, you know intuitively now what it is because you've probably seen it in paint programs. Like you've probably worked with it before, right? There's a channels dialog, right, which is this. You can actually see, I can turn off the channels and we can actually see the alpha channel by exists and where it doesn't. And it's got partial values around the edges that basically say, well, it was transitioning at this point, right? It was transitioning, it's anti-aliasing that edge basically, right? It's giving a partial value because the shape obviously can't be, it is not perfectly pixelated. The shape was actually supposed to be a smooth line that went through there. And so these alpha values are basically there to kind of smooth that out and to sort of give you that gradual fall off so it's not a hard cookie cutter edge, right? It just kind of feathers the things into the background for you. That's the way the art was set up to work. So right now we're drawing those red, green, and blue channels, but we're not doing anything with the alpha channel. And obviously, since the alpha channel is the only thing that tells us where the image exists, we need to start doing something with the alpha channel to display the person such that, display things on top of other things so that like bottom layers show through upper layers, right? And so inside our renderer, this is going to work, well, yeah, I won't say how it's going to work in the renderer necessarily. That's a little premature. So let's not say that word. Let's say a different word. What I'm actually going to say is not that. What I'm going to say is, let's talk about, for our testing purposes, what we can do is basically do exactly what Photoshop or anything else does, where we basically just think about things in terms. On top of that, what we would do is we'd essentially think of creating a separate layer, right, which has our guy on it, and basically touch what's underneath in the places where it's not. So we'll basically do compositing very much the way you would think about it in Photoshop, where you have one layer and you're basically drawing layers on top of each other, and you just don't draw where the alpha channel says there isn't anything, and that gives you the show through. So it's basically like underneath, right? So that alpha layer, the alpha channel, is basically telling us where to do the cutout. It's basically what tells us how to do the cutout. They're there. And then we've got our guy, and he's got the alpha channel on him that says where things exist. And basically, it's 0 everywhere where he does not exist. It's 255 everywhere that he does. And at the edges, it's somewhere between those two values, right? So it's basically a brightness value, you might think. What we'd like to do, right, is we'd like to think about that essentially, for now, as an opacity value, basically. To say how much of the guy blends through, partially blend on, just like in Photoshop, how you can paint the alpha channel to be some middle value, like 128 or something, that's partially translucent. We might want to do that too. So what we'd like to do is use this value essentially as a way of blending in between the two, right? This is 0 or 255. Or sort of rather on or off. So we'll basically say if it's 0, we won't draw anything. And so basically anything less than 128, we won't draw. Anything greater than 128, we will draw, right? You can pretty much see how we could do that very simply, right? Because we're iterating over all the pixels of the source++, right? So what we could do instead is both advances, right? And we could isolate just the copy like that. And what we could say is, if that source value, the source part, to do the copy, otherwise we don't. Make sense? Right? So if we did that, and we ran where he had an alpha value less than 128, and it does draw the guy everywhere there's a value over 128. And all we did was just add that one simple test, right? That's all we were doing. Now, what you'll notice is it has a very hard edge around him, right? If I was to do the zoom in on this, right, let's say we go into Krita there. I don't actually know how Krita works here. Can I do a paste as new image? Paste into new image? I don't know what you're asking me. I don't know. I don't really know how to use this program. Oh, is this what I want? I don't even know. All right, yeah, I guess it is. It's graphics. There's a lot of anti-aliasing everywhere in here. There's a lot of kind of, blurring of those edges to make them a little smoother. That's kind of the way the art works. But when we get to this guy, you'll notice there's not using any partial alpha values at all, right? We're not doing anything to try and use those values that are in between 0 and 255, which is basically a hard clamp limit, which basically just looks at the alpha value and says, I'm either going to do an operation or not based on whether the alpha better than alpha test. We'd rather do something that's actually some kind of an alpha blend, a blend that uses the alpha value to compute the, in case the alpha value is not. Now, we are going to do this in the slowest and dumbest possible way because I'd like to show the math being explicit. And so this will not be fast by any stretch of the imagination. It will be very slow. But again, we are not writing the render at the moment. What we're trying to do is... No, I'm not going to talk about how to do any of the fast stuff. We're just going to do it in the slowest possible way. So what we'd like to do now is we'd like to go ahead and labor this because there's actually... We want to rehash that entirely on the stream or just... Did that just crash? I think Krita just totally crashed on me. It did, didn't it? Ugh. Yes, it did. Krita just totally just crashed. It just full on went away completely. Come on. You can do it. It was working so well there for a while. See, image. All right, that's fine. Make the image, please. There we go. Hello. All right. Okay. So here we go. So what we need to essentially do here, right, is I want to make something the hand shape. Just is. I guess the hand was what they thought was good there. So I have a background color that's coming in, right? I've got a hand, apparently, that's drawing this now. Welcome to the mysteries of the universe, ladies and gentlemen. I've got a background pixel, so this is 1 pixel, right? I've got a background pixel, and I've got a 4. So this is whatever's in the buffer, and this is whatever's in the thing we're putting on top, right? And so in this code here, we've got a source and a dest, right? So basically, this is the dest. This is the thing we're writing to. We've got the source here. This is the source. This is the thing that we're trying to draw down. This is the guy's head, right? So this is the trees, pixels. This is the head pixels, right? So now, if we do this, what we need to do is this is some color. Let's call that color A. And this is another color. We'll call that color B. Wow. This is awful. Like, I can't even click down anymore. Ugh. These 2 colors, A and B. And what I want to do is I want to produce a third color out of these, right? I want to produce a C that's some blend between A and B. And what I want it to do is I want it to blend based on that alpha channel, right? I want the alpha. I get B. Does that make sense? So, some mathematical way of getting from A to B smoothly based on another value, right? I need, and I've got 0 at the low end, right? Essentially what I'm doing here is I'm saying I've got 2 points on this. And when I say colors, obviously, I mean 1 channel. So we could think of this as just the red channel, right? Or the green channel or the blue channel, just one of them. So when I'm going to do this, I basically have whatever was in the background, whatever that channel's color was, right? That's here. And then I have whatever the new color. And what I need to do is figure out a way to produce all of these values in between here, right? I need to be able to produce all of those values based on what touched the background at all. And if the alpha channel is 255, I'm going to drive it all the way to B, right? So essentially the way you could think about this, and the way that I usually like to sort of explain it to begin with, is that you can think of it as being based around one of the numbers. We can think of it as being based around the number that's 0 primal. So the number where we have 0 yields that value, which in this case is the background color, right? We can think of starting there. And what we want to do is we want to start there, and we want and 0 if we didn't. So how do we produce what that actual distance is, right? What's that value? Well, if you know rudimentary math, you already know what that is. It's just B minus A, right? B minus A is, if you will, almost, and we haven't talked about vectors yet, but it is essentially a one-dimensional vector, but it's basically the delta, right? It's the difference between A and B. This full portion, I would get B. And it's pretty trivial to see why algebra-wise, right? A plus B minus A, well, the A positive and the A negative cancel, and you just are left with B, which is the value that I said we would get, right? Basically, all I really need to do is take a way to only add part of this in there, right? All I really need to do is stick some kind of a percentage in here, right? Some kind of a value that's like a percentage from 0 to 100%, right? If I could just multiply this by some percentage, then I could go any percentage of the way from A to B just by changing what P is, right? A plus some percent of, if we go ahead and build on that assumption, right? If I want to say I've got A plus some percentage here, right? And also by convention, this is often called T. I'll just point that out to you. We can use that because you'll see it use this way fairly often. But some percentage of the distance from A to B, this would basically give me that value that I wanted. This would be that resulting color. This would be the color that I wanted out, right? So really all I have to do is figure out how to do this. Now what you'll also notice is I can rearrange this expression in a couple of different ways. If you know algebra, which I'm hoping everyone on this, but assuming you know algebra, then you also know that I can pretty trivially use the distributive property here to distribute T into this expression, and I would end up with these terms, right? A plus TB minus TA, right? And I can rearrange those terms any way I want to. So I could group them this way, right? I could group them here by just moving this term. This term here moves here, right? And this term stays where it is. This term slides there. If I do that rearrangement, what you can see here is these two front terms both, okay? And now you have what's usually, this is usually called a linear blend. And what it is, in either form, doesn't matter which one you find more, that's your, your starting value, one thing in that's your ending value, and basically being able to produce anything in between them by plugging in this percentage value here. But we haven't actually talked about how to actually make this percentage value work in practice. I just kind of magically waved my hand and said we had a, and if you're doing this entirely in floating point math, it could literally just be a percentage, right? You know how to translate percentages, again, if you've had high school math or whatever. 50% is O. The numbers between 0 and 1, all inclusive in there, are just those percentages. So really, in this expression, if they're what they are, they could be colors, they could be anything, positions in space, whatever, doesn't matter. This will give us a blend between them, right? I would also recommend, if you do want to go to YouTube on the handmade, in fact, YouTube Casey Muratori, I think is what you would type in here. My videos page, there is a Witness Wednesday Part 10 interpolation video, and that is a full-on 50-minute explanation. So, where are we at here? We've only got 7 minutes left, so let's go ahead and slam in the floating point version of this so that we can actually see it in action, and then about here, right? So, if I was to go in here and write the floating point version of this, let's go ahead and see what's going to basically be shifted down by 16, whatever's in that source, right? And then masked off, so there we go, and converted to a, I guess I could just do R, G, and B for short, right? The green is the 8, and that's 0. Then the alpha channel, right? I just said I need it to be a number between 0 and 1. Well, this will be a number between 0 and 255, right? So if I want to turn a number between 0 and 255, that range, right? I need to divide by 255. So that way 0 will map to 0, 255 will map to 1, and everything in between will map somewhere in between, right? So now I've got, so I'll say that my red is now going to be equal to, oh, I forgot something. I need the dest as well. So I have my source R's and my dest R. Pull out the dest R, the dest G, the dest B, and I've got my source R and source G. And to be fair, I guess I don't actually even care what these are. We don't even care if these are R, G, and B. We just care that they're channels 0, 1, and 2, right? We don't even care. So we could be wrong about these shifts, and it would exact equation that I just specified. It's going to be A plus T, A minus B if I wanted to do it that way, or I can do it this way over here. So we'll leave it that way for now, and we'll basically just say, okay, if I do one, what's my T? Well, my T is the alpha value. That's the thing that's actually causing it to work there. And then what's my A and my B? My A is going to be my destination red times my source red, because I'm trying to get to the source red, right? So that source red is the B color, and the background color is the A color, right? All right. I believe that's what we said it was, and so off we go. Now we'll go ahead. Care that they're channels 0, 1, and 2, right? So we have a that's here. Mysteries of the universe, ladies and gentlemen. I've got a foreground pixel, right? That this is the I guess I'll call this the sprite pixel, the bitmap pixel that we're drawing, right? So this is whatever's in the buffer, and this is whatever's in the thing we're putting on top, right? And so in this code here, we've got a source and a dest, right? So basically, this is the dest. This is the thing we're writing to. And we've got the source here. This is the head pixels, right? So now if we do this, what we need to do is, this is some color, you know, if I was to go in here, t times b. So we'll leave it that way for now, and we'll basically just say, okay, if I do one, what's my t? Well, my t is the alpha value. That's the thing that's actually causing it to work there. And then what's my a and my b? My a is going to be my destination red, the a color, right? All right, I believe that's what we said it was, and so off we go. Now we'll go ahead in and just do that for all of them. A, G, and reassemble the resulting value back into something that we can actually use. So what I have to do now is actually do sort of that, that is going to be our R ORed with our G, ORed with our B, but we have to now turn them back into actual that. I suppose we could just go ahead, since we know these are always positive, we could also do this as a truncation, which I think, you know, probably is a little saner here, since we are actually doing this per pixel. Per pixel things are very expensive. Probably don't want to be doing this necessarily in floating point math the way that we're doing it here right now anyway. But anyway, point being. So here we go. We're going to actually take these values and pack them back into the places that they normally go, right? Like so. We basically unpack them and pack them. Oops. 8, 16, like that. The R gets shifted back up. I think I've put everything in there. I don't know, I wrote that in pretty quickly there. We'll have to step through this and see if it works. But I believe if we typed it correctly, we should have, I'm not gonna paste things into Krita anymore. Look at what happened. Can you see in here how that looks now? Where you've basically got, you know, that kind of smooth, that nice smooth edge now that we're obeying the alpha channel. So that's, yeah, I mean, that's alpha blending in a nutshell, right? And so what kind of alpha blending actually is this? This is a straight linear blend. Right? So basically, this guy here, this is our blend equation that we're using. There are other blend equations. We need to talk about pre-multiplied alpha, because we are not talking about that after pre-multiplied alpha. But I'll just leave that for a little thing that we can talk about later on, because at the moment, it's really not something that you need to think about, whether it's pre-multiplied or not. So using pre-multiplied alpha for our final assets and so on. So, since we are basically out of time here, although I think this actually will cause us to